one. Feel free to choose the next one. So we have p prime of x equals 0.02x minus 1.45. Okay. Eli Schutz, I believe, determines that the marginal profit in hundreds of dollars, so I'll write it in hundreds of dollars per unit, of course. Okay. From selling the X parachute, okay, is given by, we copied it. Find the total profit function, P, assuming that P of 0 is 0. If we don't sell anything, the profit is 0. Okay. So we have P prime. The notation is find P of X. I will copy the constant. And now I'm asking myself, what function prime is X? What do I write? What function prime is X? Anyone, please give it a try.
X squared over 2.
Very good, awesome. Minus, I copy 1.45. What function prime? What function prime is 1.45?
X.
Excellent. Plus, of course, I always, before I look at this, I always have to have that constant in there. But now, this condition will help us find C. 0 here, P of 0 is 0, 0 equals 0, 0, C. Okay, fine. So then C is 0. Perfect. So I simplify, so then P of X equals 0.01 X squared minus 1.45 X. So we found the profit function from the given marginal profit function. We were given the marginal profit. We were able to find the profit function by anti-differentiating. How do I know this is correct? Because when I differentiate this, I have to get that. Look, bring down 2, I get that. Negative 1.45x prime is this. Now, that was part A. Let's take a look at part B. How many parachutes does Eli Schutz need to sell to break even? What does that mean to break even? In other words, no loss, no gain. What do we mean by break even? What did we do a long time ago to find the break even point? How did we find that? So this is part A, this is part B. How do we break even? When profit is no loss, no gain. So we break even when the profit is equal to no gain.
0.
Exactly. No gain, no loss. Good. So 0.01 x squared minus 1.45x equals 0. Of course, I have to factor out x. Yes, one solution is 0. Of course, if we don't manufacture anything, there is no profit. And the other option is when this is 0. 0.01x equals 1.45. So x equals 1.45 divided by 0.01. We multiply top and bottom by 100, and we get x equals 145 units. If we're asked to find the break-even point, but we're not. So the break-even point is 145, comma, revenue at 145. Not profit, because that will be 0. Okay? So the break-even point is the number of units, comma, the revenue, but we don't have the revenue, so they're not asking us to find that. Any questions on this problem? Any questions on this problem? Any questions? Anyone?
No,
Okay,
I got it.
okay. Now I would like to continue with section 4.2. We're not going to be able to finish section 4.2. I have a lot to tell you in 4.2. More than I told you in 4.1. 4.2, areas. And you can say, what are you talking about? I will explain step by step. Okay. So what is all this? Areas? Where from? What is this? Okay. So let's look at a very simple function, x squared plus 1. I'm going to graph it. I'm going to pick an interval, not everywhere, a small interval, let's say 0 to 2. So this is 0, this is 1, this is 2. If I plug in 1, so at 0 is 1. When I plug in 1, 1 plus 1 will be 2. When I plug in 2, 2 squared is 4, 4 plus 1 is 5. 2, 3, 4, 5. So here's the graph of this function. I didn't mean to go that far. And we are asked to find the area under this graph between 0 and 2. So I'm basically asked to find this area. So this is f of x equals x squared plus 1. So I'm asked to find this area. First of all, let's discuss why. Now we can discuss why. Why? Who cares about this area? And why would I even care about this area? Okay, here's the reason why we care about that area. Assuming that this is the velocity function, if I determine this area under the graph of the velocity function, I will find the total distance covered on this time interval between 0 hours and 2 hours, or 0 minutes and 2 minutes. Doesn't matter. On 0, 2. That's the reason why I want to find the area. Let's say this function is the marginal profit. Let's say this function is the marginal profit. What do you think the area will represent? If this function is 0.02x, it's not, but assuming it's 0.02x minus 1.45 between 0 and 2, because it's marginal profit, I would say between 0 and 2,000 units, or 0 and 200 units, whatever. Okay? What will the area represent? So let me repeat the question. If this is the velocity function, the rate of change of distance, if I manage to determine this area, or even approximate the area, I will determine close to the distance covered between this and this. Now, if this is the marginal profit, what will this area represent? If this function is the marginal profit, what do you think? It's okay if you're wrong. If you're not wrong, then I don't have anything to teach you. I don't have anything to say. So if this is the marginal revenue, or if it's the marginal profit, or if it's the marginal cost, what do you think the area will represent? Anyone, please say something, anything. Anyone, please?
Can you ask the question a little differently? I'm trying to like.
Yes. Absolutely, let's do that. Because this is very important. Remember, we had that situation in which I was asking over and over the same question. So when we had that f of x and the tangent, and I was asking you, let's say at 1, 10, and I was asking what is the slope of this line, the tangent line. And not everyone answered f prime of 1, but it's f prime of 1. So this is a very important topic. Now the next one is also very important. So let's suppose I have this function between 0 and 2, and the function is the velocity. If the function is the velocity between 0 and 2, this area is the total distance covered between 0 and 2. If now I have marginal cost, let's say this function is the marginal cost, what will be this area? All this area under the graph.
The revenue?
Yes. But the cost, we're talking about cost. It will be the total cost between manufacturing between 0 and 200 or 0 and 2000 or whatever the measurement unit is. So this is the total cost. Okay, one more. What if I have now the marginal profit? So this function is the marginal profit. I'm still using 0, 2 because I want to go back to our example. What will the total area, if I manage to determine this area somehow, what will that represent?
Total profit.
Exactly, exactly. Only between 0 and 2, not more or less. That's it. So that is the reason why we are learning right now in 4.2 how to determine these areas or approximate them at first, and then we'll determine them exactly. But at first, we're going to approximate them. Awesome. Is that clear so far? You don't know how we're going to do it, but is it clear that if this is the derivative, the area under the derivative will be the total whatever it is? Yes?
Yes.
Perfect. Okay, so I'm coming back to the example because the technique, we have to learn the technique of finding the areas now. We know what it represents, but how do I find it? So let's find it. So I'm back to the same example. I'm back to the same function, the f of x equals x squared plus 1. So we want to find the area under this graph between 0 and 2. Under f of x between 0 and 2. Why? We know why. How do we do it? I'm going to say using 2 subintervals. And leftmost point. This is part A. Part B, same number of intervals using 2 subintervals and write the rightmost point. And you can say again, what are you talking about? And I am explaining right now. Okay. So the interval is 0, 2. I am going to approximate these areas using 2 subintervals between 0 and 1 and 1 and 2, and using rectangles. I don't have a way of determining this area exactly. We will later on. Because it's not a square, it's not a rectangle, it's not a triangle, right? So I will use rectangles to approximate it. I'm using 2 for now. And now I want to use the leftmost point. What does that mean? The leftmost point means where the function sits. On this interval between 0 and 1, the height is the leftmost point. So then I draw from that height where it hits the function, and this is my first rectangle. The next rectangle starts at 1, where the vertical line at 1 hits the graph. And then I go to the right, and this horizontally, and this is the second rectangle. You can say, but this is nowhere near the entire area. That's true. It's not. But that's all I have for now. When I calculate these areas, very simple. Base times height plus base times height. So the areas of these two rectangles, the area with left two subintervals is base, which is 1, times f of 0, plus base, which is 1, times f of 1. So times 1. And I'll calculate in a minute. Before I do that, I want to ask you a quick question. This area, will it be an underestimate or an overestimate of the exact area? Under or
Under.
Of course, because I'm missing these pieces. Of course it will be an underestimate. Okay, so let's see what it is. So L, the area with left 2 subintervals, is 1 times f of 0. 0 plus 1 is 1, plus 1 again, which is the base, the width of the subinterval, the width will always be equal, times f of 1, which is 1 plus 1, which is 2. 1 times 1 is 1, 1 times 2 is 2, 1 plus 2 is 3. Underestimate. Perfect. Let's see what we get with the rightmost point. Still the same graph. Still 2 subintervals, 0, 1, and 2. But now base times height and go horizontally. Base times height and go horizontally. This is my first subinterval with the rectangle corresponding rectangle, and this is the second subinterval with the corresponding rectangle. I have to stop where the function is and go horizontally to create the rectangle. Stop where a function hits at 2, f of 2, and go horizontally and create the rectangle. The area with right 2 will be base times f of 1 plus base times f of 2. Will this be an underestimate or an overestimate of the correct area? So this is 1 times 2 plus 1 times 2 times 2 is 4 plus 1 is 5. So this will be 2 plus 5 equals 7. Do you think that this is an underestimate or an overestimate of the actual correct area?
Over.
Of course, by a lot. Overestimate. Perfect. So we know that the actual area, the exact area, is somewhere between 3 and 7. It's not 3 and it's not 7. Okay, perfect. Now for the same, so I got some estimate. For the same function